There are four main types of plate margin or plate boundary. In this video, we are going to focus on three of them. We have constructive, destructive, and conservative. You can see the constructive has plates moving away from each other, destructive has plates moving towards each other, and conservative has the plates moving alongside each other. To help you remember this, you can imagine it like a building. If I am building a building or constructing a building, the amount of land is increasing, or the building is increasing in size, and that is therefore a constructive plate margin when new land is being built or made. If I'm destroying a building, the amount of land decreases and is being destroyed, as you can see here on a destructive plate margin or plate boundary. And finally, we have got a conservative plate margin. That is if the building remains exactly the same. There's no land added and there's nothing destroyed. That is a conservative plate boundary. We're going to look at each of the three now. We're going to start with a constructive plate margin or plate boundary. This is where land is being made and you have two oceanic plates or oceanic crusts, and you can see from the arrows they are moving apart from each other. They're moving away from each other. I'm going to explain to you what is going on here. So, first of all, we have convection current in the mantle, causing the plates to move apart. Now, we looked at convection current in week 4, so hopefully you'll be familiar with these. As the plates are moving apart, it creates a gap in the crust, and magma can rise up in this gap, which you can see here. The temperature at the crust is much cooler than at the mantle, so the magma that comes through cools and it forms a new crust. Over time, this process forms a volcano. It's not a very strong volcano, it is what we call a shield volcano. Pause the video now to make some notes. You might want to copy the diagram down. At a destructive plate margin, the land is being destroyed. You have one oceanic plate, you can see that here, and one continental plate, you can see that here. The two plates are moving towards each other, shown by this arrow and by this arrow. Similar to at a constructive plate margin, the convection currents in the mantle cause the plates to move towards each other. The oceanic plate is more dense, which means it's heavier, so it subducts, which means it goes under the continental plate. This builds up friction and pressure here on the diagram. The friction is eventually released as an earthquake, and this releases something called seismic waves. You'll find out more about them in just a moment. As the oceanic plate continues to move into the mantle, it ends up being melted because of the heat in the mantle, and it gets destroyed. Over time, the pressure down here in the mantle builds up, and eventually the magma will rise up through the crust. It will find a gap in the crust, will rise up through, creating a volcano. Now, not like a constructive plate margin when we have a very gentle volcano. These volcanoes are very explosive. Pause the video now to take some notes. Again, you might want to copy the diagram and you might want to make a note of these 6 points here on the right-hand side. Finally, at a conservative plate margin, where the land is conserved or stays the same, you have two plates which are moving alongside each other. In this example, you can see the plates are going in opposite directions. However, you can, at conservative plate boundaries, have the plates going in the same direction, just at different speeds and different rates. I'm going to explain to you what goes on at a conservative plate boundary. So as always, the first point is the convection currents that take place down here in the mantle. And these are causing the plates to move, and as a result, they slide past each other. As the plates rub up against each other, friction and pressure builds up, like at a destructive plate margin. Once the friction builds up and is released, this causes an earthquake. Seismic waves are radiated from the earthquake. You can see that in the red circles at the bottom of this diagram. And where the earthquake reaches the surface, this area is known as the epicenter. That's just here on the diagram above the red dot. Now, there's a key difference between the focus and the epicenter. The focus is what takes place underneath the ground. That is where the earthquake starts. And in the epicenter is the name for the place immediately above it on the ground, shown in both diagrams on the screen. Again, pause the video now, take some notes. You might want to copy down the diagrams. You might want to make a note of the instructions on the right-hand side. After you've done this, read through the rest of the worksheet and make sure you answer the questions at the end of the sheet.